Hello guys, welcome back to STEM Trainers. Now today we are going to see kinematics using calculus, that is variable acceleration case. Now in the previous videos we have seen the constant acceleration case, that is velocity time graph, distance time graph and the Surrey equations. Okay, so let's first look at differentiation. That is basically velocity is nothing but ds over dt. That is the first thing here. Second thing, acceleration is, we know this in velocity time graph, it's a gradient. So basically dv by dt, that is rate of change of velocity with respect to time, gives us acceleration. So from that we can easily see these differentiation formulas. So now let's come to the integration part. So I can use these differentiation formulas to find, so for example, v equal to ds by dt. So I can write v dt is nothing but ds. And then I can integrate both sides. Then I will get displacement equal to integration of v dt. V is velocity, t is time. So I get this formula, that is third one. So now similar way, if I use the second one, that is acceleration equal to dv by dt. So I can write a dt is nothing but dv, and then I integrate both sides. So I will get velocity is nothing but integration a dt. Now these integrations, we know there are two types, indefinite and definite. Indefinite means where we use a constant of integration, and definite means we have limits, lower limit and upper limit. So we will understand which integration we have to use, definite or indefinite, when we will solve questions. You will understand more in that. So these are just the basic four formulas that we will be using in variable acceleration cases, or you can say while using the calculus. Okay, so let's try some questions on this and let's see how to apply them. That's the most important part, I think. Okay, so first question is, a particle P is moving on x-axis. At time t, the displacement x meters from O is given by, okay, x equal to 2t cube minus 8t. Find the velocity of the particle at 3 seconds. Okay, so displacement is given, and we know that velocity, a part, is nothing but ds by dt. That is, in this case, we can say dx by dt. So let's differentiate this. X, this is my x now. Let's differentiate. So differentiation of 2t cube is 6t square minus 8t differentiation is 8. So this is my velocity at time t. So now I need at 3 seconds. So time is 3. So what's my velocity? So this will be 6 into 3 square minus 8, which is coming out to be 46 meter per second. So that is my answer. As simple as that. Okay, let's try B part now. Acceleration. Acceleration of the particle at time equal to 2 seconds. Okay, so we know acceleration is gradient of velocity time graph, that is dv over dt. So let's first find this value. Differentiate velocity. So this is my velocity, right? 6t square minus 8. If you differentiate this, you get 12t. And differentiation of 8, that is a constant, is 0. And we need a time equal to 2 seconds. So let's substitute t as 2. So I am getting acceleration as 12 times 2, that is 24 meter per second square. So this is my B part. I hope everyone understands. This is just basic application of the basic formulas. V is dx by dt and acceleration is dv by dt. Okay, so let's try more questions on this. Second one. A particle P moves on x-axis. Okay, at time t seconds, the velocity of P, that is a particle, is v meter per second in the positive x direction. Okay, where v is equal to this. Okay, so velocity of particle at time t seconds is given 3t square minus 4t plus 3. Okay, so when t is 0, particle is at origin. Okay, so basically we can say particle starts from origin. Find the distance of p from O when p is moving with minimum velocity. Okay, so now we have to use little bit more of calculus. Minimum velocity. So we already know the velocity, right? Velocity is 3t square minus 4t plus 3. As we can see, when we time will change, as time will increase, so velocity will be increasing or decreasing. It's a quadratic function, right? So at some point, it might be getting a minimum velocity. So first we need to find where it attains minimum velocity. And then at that time, we need to find where the particle is as compared to origin. So basically we need to find the distance between that point and origin. So that's the question. Okay, so I think everyone understands the question now. So let's first find where actually at what time velocity is minimum. So how do we find velocity to be minimum? So in calculus you have learned that wherever dv by dt is 0, it gives us stationary points, right? So at stationary points we can have a local minima, at stationary points we can have a local maxima, that is minima or maxima. So basically first we have to find where dv by dt is 0. So let's calculate dv by dt. Now velocity is 3t square minus 4t plus 3. So what is dv by dt? So this will be 6t, differentiation of 3t square. Differentiation of 4t will be 4, so minus 4. And differentiation of 3 is 0, equal to 0. So I'm calculating when is dv by dt 0. So from this I'm getting my time as 4 over 6. That is nothing but 2 over 3 seconds. Okay, so at time equal to 2 over 3 seconds, I have a stationary point. But I don't know whether it's maximum or minimum. So let's find that also. We know that if d square v by dt square value is positive, then we get local minima. If that value is negative, then we get maxima. So let's find d square v by dt square. So let's double differentiate this. 6t minus 4, differentiation will be 6 only, which is positive. It implies that the local stationary point will give us minimum at time equal to 2 by 3 seconds. I hope everyone understands this. So you have studied this in differentiation, year 1, that if d square v by dt square is positive, that is double differentiation is positive, then at that point we get minimum. So it means when time is 2 by 3 seconds, we get minimum velocity. Now the question is, we need to find the distance, right? Distance means we need to find displacement. So where particle is. So for that, we need to use what is displacement. Displacement is nothing but integration v dt. Correct? So now we will see how to use integration. That is actually more important because that is where actually students struggle or they miss some things here. Okay, so let me first write this. So displacement is v dt. Now there are two things. First is you can use indefinite integration, that is you don't use the limits, and you can use c here, that is constant of integration. Or what you can do is, what I like is you directly use the limits, that is you make it definite integration. That is actually much faster and quicker. So let me show you how to use that. So basically very simple thing. So how do we use is, so let me just write here. Or I can, in one question, I can show you both methods. I think it's better. Let me show you both methods so that you don't feel like what is indefinite integration, what is definite integration. So let's first use definite integration. So my ds is equal to v dt integration, right? This is what we derived. I hope everyone understands this, right? Okay, so now let's use the limits. So when time, so these limits in the right side, the integration is on dt, right? So it is with respect to t. So basically when time is 0, what's my displacement? That is at origin, let's say 0. And when time is 2/3 seconds, what's my displacement? That I have to find out. Let's write that as s. I hope everyone understands the limits. These are important. When time is 0, my displacement particle is at origin. So let's say the position is 0 because it's moving on x-axis. So it has only x coordinate. And when time is 2/3, let's say it is having a displacement of s. Okay, so if you integrate the first one, you get s only. Actually, you get s minus 0, that is s only. Second one, v dt. So what is my velocity? 3t square minus 4t plus 3. So 3t square minus 4t plus 3 integration 0 to 2/3 dt. So which will be nothing but integration of 3t square will be t cube minus 4t square over 2 plus 3t. And we have to use the limits 0 and 2/3. Okay, so let's substitute the values. So when you substitute 2/3 in this, we will get 38 over 27. And when you substitute 0, so as every term has t, so it will be 0. So s will be 38 over 27 meters. So when time is 2/3, particle is at a distance of 38 over 27 meters from origin. That is my answer. So this is, we are using definite integration here. Now, you can see if you don't use definite integration, then what will happen is you will get 38 over 27 plus c, right? Because your integration will be t cube minus 4t square by 2 plus 3t plus c. Okay, let me just show you. So this is finished now. This is it in definite integration. So if you use indefinite, what will happen is you will have some c here. And then 38 over 27 plus c, that is my value at 2/3. And my value at origin will be 0 plus c. And when you subtract them, because you need to find distance, right? So one position that is at time t equal to 0, one position that is by time equal to 2/3. So here the position is 0 plus c because we are using indefinite integration. And the second, my position is 38/27 plus c. Now to find the distance, obviously you need to subtract them. So when you will subtract, c will cancel. You will get 38/27. So that's basically, you obviously you will get the same answer. It depends on you which method you like. Generally, I think the definite integration one is fast. It has less calculation also. Okay. So I hope everyone understands this. Okay, let's try one more question. So this is our answer for this one. Okay, let's try third question. Particle P is moving on x-axis. At time t seconds, its displacement is given by this. Okay, so we know the displacement as a function of time. Find the distance between the 2 points where P is instantaneously at rest. Okay. So what do you understand by instantaneously at rest? So instantaneously at rest means, obviously now you can see x is a function of time. So obviously velocity will also be a function of time, which will be a quadratic, we know, after differentiation. So obviously when time changes, velocity changes. So at some point there might be that velocity is zero instantaneously at rest. It means basically is velocity or instantaneous velocity is zero. So first we need to find 2 points. Now they are saying there are 2 points. So we need to find the 2 points where velocity is zero. So for that, first we will need velocity. So let's first find velocity. Velocity is nothing but ds over, or dx in this case over dt. So let's first find this. So this will be 12t square minus, this will be differentiation of this is 78t, and this is plus 120. So this is my velocity. So I need to find where velocity is zero. So I will equate this to equal to 0. And I will have to solve now for t. So I think we can divide this by 6. So let's divide this by 6. So what we are getting is 2t square minus 13t plus 20 equals 0. So let's try to make factors of this. 2 into 20 is 40. So 8 and 5. So let's make factors. 2t square minus 8t minus 5t plus 20 equals 0. And this will be nothing but 2t, and this will be t. So t minus 8 and 2t minus 5 equals 0. So I'm getting here as, so this will be t minus 4, should be 20, right? Okay. So these are my factors. So my time value where velocity is 0 is 5 over 2 seconds and 4 seconds. Okay, we got two values. That is what we were looking for, 2 points. Okay, now we need to find the distance between these 2 points. So obviously now we know we have x value. Now our x is 4t cube minus 39t square plus 120t. So we can find out when time is 5 over 2, what is my x here? So let's substitute t as 5 over 2. So you will get the value as 118.75. So what we are doing in this is we are just substituting time as 5 over 2, that is 2.5 seconds. So you can substitute t as 2.5, like 4 into 2.5 whole cube minus 39 into 2.5 square plus 120 into 2.5. So we will get 118.75 meters, let's say. No unit is given, so okay, square unit. We can take any unit. Okay, now at 4. So substitute t as 4. So what is my x value coming out to be? So my x value will come out to be 112. So I need to find the distance between these 2 points. Now as the particle is moving on x-axis, so the distance will be subtraction of this. So the distance between these points will be the difference of them, right? So what's the difference? 6.75. So that is my answer. Now no unit is given, so you can just use any unit, 6.75 unit, whatever it is. Okay, so this is how we can find when particle is instantaneously at rest. So that's the most important thing. Rest is calculation. Okay, let's try one more question. The particle P travels in a straight line. The velocity of P at time t seconds after it passes through a fixed point A is given by this. Okay, so basically it is saying that at time t equal to 0, particle is at A. That's what they are saying actually. Okay. And find the velocity of P when it passes through A. Okay. Displacement of P from A when time is this. Okay. So many parts. So let's try solving one by one. So let's first try A part. Velocity of P when it passes through A. So now we just figured it out. When it is at A, time is 0. It starts from time t equal to 0. It says something like this. So this is my velocity. Velocity is 0.6 t square plus 3. So when time t is 0, my velocity will be 3 meter per second. So that is the first part. Okay, so when particle is at A, its velocity is 3. Okay, let's try the B part now. The displacement of P from A when time is this. Okay, so we need to find displacement. So basically we have velocity. This is velocity. So from this we need to find displacement. So what we need to do is integrate. I think we just did similar question like this. So V dt, we need to integrate this. So let's use the definite one because it takes less time. So at time t equal to 0, particle is at A. So let's write SA. It's not given its origin, so let's use SA. So when time t is 1.5 seconds. So let's say it is at point B. So its displacement is SP. Okay. So let's integrate this. So we get SB minus SA equals integration of V dt. V is 0.6 t square plus 3 dt from 0 to 1.5. So what we will get here is, let's integrate this. This will be 0.6 t cube over 3 plus 3t, and the limits are 0 to 1.5. So first we will substitute 1.5 in this, then minus we will substitute 0. So obviously when we substitute 0, it is 0. So when we substitute 1.5 here, so we are getting value as 5.175 meters. So basically that's a distance between the points. Displacement of P at time t equal to 1.5 seconds. I hope everyone understands this. Okay, let's try C part now. What it says in C part, velocity of P when it has acceleration of 6 meter per second. Okay, velocity is given. They are asking for acceleration as 6. So let's first find what's the acceleration. dv over dt is acceleration, that is differentiation of 0.6 t square plus 3, that is 1.2 t. So my acceleration is given as 6. So obviously 6 will be equal to 1.2 times t, right? Because this is my acceleration. So what's the time here? Time is 6 divided by 1.2, which is 5 seconds. So at 5 seconds, my acceleration is 6 meter per second square. So we need to find velocity at time 5 seconds. So velocity is 0.6 into t square plus 3. So this is my velocity at time t equal to 5 seconds. I hope everyone understands this. That's it for this. Using calculus, how to use how to find velocity, acceleration, and displacement. So that is all there is basically these four formulas, how to apply them. It's very important, and keep on practicing if you are having some problems, because it takes some little bit of time, especially the integration questions when you are doing integration. So at that time there might be that you are making some mistake in constant of integration or using the limits, lower limit, upper limit. So just write 3 4 more questions and then you will be comfortable in this. Okay, thanks for watching STEM Trainers.